Hello everyone, Sigmas here, and today we'll be continuing on our snake game series. This is the second part, and we will actually be doing our player, so our snake, as I've said in the previous video. We will be including our inputs, what a snake would look like, and the snake movement, and all the things that a snake does. So yeah, I guess we'll get started into it. First thing we need to do is we actually need to include another library. This would make us include the inputs to our system. So when we run the program, it will take in an input, and yep. So this is the library that we need to put. It's just conio.h. Not really sure what that stands for, but yep. So we need that, and then now we gotta set a variable. So we're gonna set a new variable. I'm gonna put it in the, I'll just go here, I'll just make this user variables, and then this one would be target variables. Sorry, I'm just putting comments to make the code pretty clean. This would be game variables, even though I should probably put this up with these with height. Anyways, but we'll go to user variables, and we'll create another variable for that, and we'll call it what's a good variable? Speed. We'll call it speed. So this is the speed SPD of our user. Now that's that's the variable we'll create. We don't need to set it up yet because we already got the X and Y variables set up. Now we just need to draw it. So where it would appear in the game. So obviously it would appear not in the borders, but in the middle. And what it's actually going to do is, like, if I can get my paint here. So we got the borders there. And is that we have, you know how we have a asterisk, and then we have, let me just do another color again. We have yellows, and I'll just do this instead. We have a yellow space, and then we have another asterisk here. So it's asterisk space, space, and then asterisk. What we'll do is that in the random position, we'll actually go asterisk space our user, and then space, and then asterisk again. So that's what's going to be happening, and each time it's going to clear because of the system clear over here, and then it's going to create the next position of the user. So next thing, the user might not be here, but instead like over here or here or here or here. So that's pretty much what we're going to do, is that we're going to create the user in between the spaces. So we'll go ahead, go to our game window, and here in the body, I'll clear this up. So that's the top border. We've got the body, and we've got the bottom border. So there you go. In the body, right, what we will do is we will implement our snake. So after this, after we create the space, what we'll actually do is go an if if the I, so if the height of our code is equal to the user, so we'll go the X, user X, wait, no, sorry, it's height, so user Y, and our J, so the width component, is equal to our user X, then we will draw our player. So that would be cal, and we'll say our snake as, what's a good letter for snake? S, I guess, S for snake. I'm not sure, but yeah, I guess S would suffice. So there you go, and that should actually print out our snake in a random position. Let's go check that out. If it loads, and boom, see, our snake is right there. Now it is producing another space there. I think it's because it's doing the else here. So what we will do is we're actually going to create this. We are actually going to create this into an else if statement. Now this isn't gonna work. I actually have to move this up here, and that's totally fine. There you go. Now that should work. What it's gonna do is that it's gonna create the borderline at equals 0 and -1. Else, if I is equal to y and our j is equal to x, so our height is equal to our player y, and our width is equal to our player x, then we will print out our player. Else, if it's not equal to these, or if it's not 0 or -1 of our width, -1 of our width, then we're gonna print spaceline. So that's pretty much saying is it's gonna recognize this first. It's gonna recognize our border first, our asterisk, and then it's gonna say, let's say our player was, actually I'll do here. So recognize the axis, and let's say our player was here. So this is our this is our player, and what it's gonna do is gonna realize, okay, I does not equal y, j does not equal x, and boom, I equals y, I equals x, therefore print ds, and then otherwise just print the the space. So yeah, we got that. Now let's try that. It shouldn't add another space onto the borders, and there you go. See how it didn't do what it did before, where the asterisk was over here. Alright, so we got our snake done. Now all we need to do is do its movement. Pretty much, again, we're gonna clear up the screen, and then we're gonna draw it, clear up the screen, draw it again, clear up the screen, draw it again. Now, because in our main, what we actually did was we set this once, to run once. So we said, set up the game, draw the window, get the inputs, and do the program. So what it's gonna do is it's gonna set up the game, draw the window, but it's not gonna draw it again. It's just gonna draw it once, and then it's gonna get input into the program. So we needed to draw multiple times because our player will be moving, and we have to keep clearing it and clearing it and clearing it. Therefore, we have to keep calling this function of game window. And so what we'll do is we'll do a while loop. So while our and we'll actually do this, we'll reference to the Boolean snake game. So while our Boolean snake game snake game is equal to true. So while this is happening, we will keep running our game. There you go. Now that's actually gonna make a really flashy output. See, as you see there, it's flashing everywhere. But that's what we want. That means we can move our snake. It's gonna keep clearing. Move the snake. Clear. Move. All right. So that's good. That's good so far. Now we are gonna implement our input. So that's what our library there was for. Is we're gonna get the user input. So let's go to our game input, and we will use a function from the library underscore kb hit, and that means if our keyboard has been hit. KB is short for keyboard. So we'll go if our KB has been hit, if our keyboard has been hit, we will do things. Well, first we need to get which key we hit. So that would be if our let's say underscore get ch, so get the key that was hit, and we'll get the A key, or we could use the up, down, left, right, but we'll get the WSD key for now. So let's go get the A key. If that has been hit, then we will say pretty much use our directions here. So we have made directions here, move up, down, left, right. So if our A key, which is the left one, is hit, then dir is equal to left. Now, the only problem with this is that I have to make multiples. I can go if I have to do another one, get ch, get character, and it's gonna be s, and it's just gonna be a long process of just typing the same thing. What we can do though is a cheat that I found. All we have to do is do a switch. Now switch is pretty easy. Switch get ch. So we're gonna switch our get ch character. And that's what that's basically gonna do, is it's gonna switch from different cases. most of you would probably know what a switch is already. So it's basically going to go case, as an example, case A. So if I hit the A button, then, you know, it's already going to go get ch A, and it's going to implement stuff to it. Of course, what we put to it, so we can put whatever, and then we'll break the code. Therefore, for that case, that's what's going to happen. That's pretty much what the cases are, and then we can say case if we hit S this time. Things would happen, and then the code will end. So that's what we want. It's easier than using the if statements for each and every one. So here, case A, we have to set the directions. So dir, I should say, is equal to left. Now, another problem that occurs with this, as you see, there are like many problems with programming, is that when you play Snake, you do not want to hit left and then go right. So hit left and then, you know, hit right to go right. Because then our Snake would just, if I can, that's not how you do it. If I can just delete this. Okay, that is not how you delete it, but that's fine. I guess I can work with a yellow background. No, I cannot work with a yellow background. Can I get? Nope, I cannot. All right. Let's just delete. I think that's the... Yeah, no, I cannot work with paint. I have no idea how to work with paint. I don't usually use paint. I'm this bad at paint. Anyways, so imagine our Snake. It's right here. There's our Snake, and it's got a long tail. It's got a really long tail. In the normal Snake game, if you actually hit your tail, it's game over. Now, what happens if our Snake is here? It's going this way, so it's traveling this way. It's got a tail, and then suddenly we hit right. So our keyboard first goes left, and then we hit right. Obviously, the Snake will go backwards, hitting its own tail, making it, well, pretty much end the game. So we do not want to make that mistake. What we'll actually do is we'll create an if our dir, right, our direction does not equal to, does not equal to our right. So this is saying if that our direction does not equal to the right, then we will run the code. We'll just put this there, so we will run the code. Alright, that sounds good. So pretty much if we hit A and our direction does not equal right, then we will go left. This is for literally every single one. So this one, if our direction does not equal, and since S is down, therefore we'll go, if it doesn't equal up, then our direction would equal down. Same thing would happen, case for D. If our direction does not equal left, then our direction would equal right. Right. There you go. Oh, and don't forget to always break a statement. Otherwise, the code will just continue forever. So case W. If our direction does not equal down, then we will change our direction to equal up, and then break the code. Alright, so that's pretty much our keyboard input. That's literally all we have to do. We might want to do a case default here. So this is if there is no other case. Oops, that is not how you spell default. And then we'll just return 0. So we'll just end the game. That should be it. What we'll actually do is we won't do a case default. We'll just do an end game. So let's say it just ends the game. We'll make that the key 0. So we'll go with 0. So if we press 0, then we'll just end the game. What we can do is just go snake game equals false. Alright, that should be good. Now, if we run this, we just change direction, so nothing would happen if we do the WASD. But once we press 0, it will end the game. So as you see, press any key to close this window. So we'll close that. There you go. So that's our keyboard input. And now we actually have to draw this keyboard input. Or more like, set it to actually work. Now what we'll actually do is we won't draw it, but we'll set our position X and Y to change each time. So in our game program, what's going to happen is we would have another switch, and this would be based on our directions. So we'll hit tab on that one. And we'll do a case again. And if our switch, our direction, is equal to left, there you go. If it's equal to left, then we'll get our X value. So this is the X of our snake, to add 1 each time. So each time our case is left, we add 1. I'm pretty sure we can actually go plus equals 1. Or better yet, plus equals speed, because we created our speed variable right here. We haven't set an amount for speed. Speed equals, let's say 2 or 1. That's better. So we'll set an amount for our speed. Speed is equal to 1. X plus is equal to speed when our case is equal to left. Same thing when our case is equal to up. Then our X, oops, I put it outside the switch case. Pretty shouldn't do that. We also need to break the switch. Case is equal to up. Then Y is going to be minus equals our speed. Now you may wonder, why is it minus when it's going up? When in the Cartesian plane, we actually, positive was up and negative was down. Well, the only reason why it's minus is because this corner right here in our boundaries, so in our boundaries, this corner is considered 0, 0. So pretty much our Cartesian plane is here. That's our origin. And here, when it's going up, it's actually heading to minus 0. That is a wrong analogy. Our Cartesian plane isn't there, I should say. What am I saying? Let's draw this again. All right, so again, our point here is 0, 0. That's correct. And let's say it's a 32 by 32. Therefore, our point here is literally 32 by 32. Now, as you see, as it goes up, it gets closer to 0, making it minus. So 32, to get to 0, it has to actually minus 32. So going up there, it subtracts 32. And going here, it also subtracts 32. But from here, when you go right, it adds 32. And when you go down, it adds 32. So again, going up would subtract, going down would add, and going right would add, but going left would subtract. So that's the concept behind this. When you go up, you actually minus. Hopefully you guys understood that. If not, feel free to and ask me more questions in the comment section. And going down, y plus equals our speed. And we'll break that. Case right is what we forgot. And that would be x. Why did I say plus equals here? That's actually minus. Minus equals x plus equals our speed. And we break. Alright, so that's literally all we need to move our snake. Let's go try out what we've done here. And it should actually work. First, we're not going to move because we set in the game setup to stop. Our snake is going to stop. And we're going to set the direction to right. So we're going to move right. As you see, he keeps moving right. He goes past the border. And I'm not sure if he's coming back. Okay, he's not coming back. The only reason why he didn't come back is I actually pressed left when he was going right. Which, remember, we said we cannot press down while we're going up, or left while we're going right. So I had to go like kind of like that. So I had to go in the box area to be able to shift it. But see, now we've got our snake moving. This is pretty much the snake game, guys. Okay, that's the end of our series. Have a go on. I'm kidding. All right, we are not done yet. We still need to make a lot of things. We have to make the tail, the fruit, or the target, I should say, and you know, our snake cannot hit walls. We'll actually do that first. We actually make it where the snake cannot hit the wall. So in our logic here, in our game, not input, actually in our program. Why am I in the input? In our program. All right. We will make it so that if our snake hits the walls, then game over. So if our x value is equal to 0, or that's the symbol for or, our x value is equal to the width. So that's if it hits the left and the right border. Didn't we say width minus 1? Width minus 1. Okay, sorry. Width minus 1. Let's do that. Or, same with our y's. If our y is equal to 0, or our y is equal to height minus 1, then it's gonna be pretty much game over. So unlucky, snake. You've had a good life. Not really, but it's alright. So snake game equals false. So we are not running the snake game anymore. Now let's try that. Let's actually try this. And there's errors. Okay, we always get errors. Isn't that fun? There's a missing this before the this. Break. We're gonna add this, and that would be this. For the switch, it'd be here. And for the if, it'd be here. Oh, there's the line there. All right, what are we missing here? Here you go. There it is. All right. Oops. No, that is not what I want. That is also not what I want. There. Okay, that should do the job. Let's try that again. And there you go. All right. Now, if we move left, it should end once we hit 0. Nope, it doesn't end. Okay. That means we did something wrong. If x is equal to 0, or yeah, it should work. If x is equal to 0, or x is equal to width minus 1, and if y is equal to 0, or y is equal to height minus 1. What am I missing here? While snake game is equal to true, run the program. Yep, x plus equals speed. Is it because, Alright, we'll develop a better, instead of doing equals actually, what we'll do is that if our x is less than or equal to, we'll do that, less than or equal to 0, and if our x is greater than or equal to width, this means that any value lower or higher would cancel it. I think this is a better way to do it. Alright, let's try this out now. Let's go, and that should work. Okay. Let's just remove the equals to. X is greater than, am I doing this correct? Our x is less than 0. Yes. Our x is greater than our width minus 1. Our y is less than 0. Or our y is greater than the height. Yep, that should actually be correct, unless I'm really off tonight. Alright, let's try. It should end, please. Nope. Okay. Oh, I think that was my bad on that side. Let's actually try again. You know what's better? I think it's shorter to go this way. No, it didn't end. Huh. What am I still missing? We set our snake game equal to false. So if our x is 0, or our, yep, is it the minus ones? It should still work. Oh, okay. I see. So yep, we'll set this back to minus ones. The problem there was that I actually instead did snake game is equals, or this is what the double equals is saying, is that it's checking. Double equals means it checks if it's false. So this basically saying, is snake game false, question mark, instead of this where snake game is false. This is setting snake game to false. This is checking if snake game is false. So we'll do that, and we'll do it like this just in case our values would equal to 0, or our height minus 1. Now that should work, because we are setting our snake game to false now. Therefore our snake game shouldn't be working anymore. And boom, there you go. The snake game finally doesn't work, which is what we want. And that's pretty much it. We've got our borders down set, and all goods. I wonder how long this recording has been going for though. 20 minutes. I think that should actually do it for now. We've pretty much got it down flat. We've got the snake moving. We've been drawing the snake, and we've got our snake to be able to hit borders and die, pretty much. That should be it for the snake, the main body of the snake, of course. We are going to do more on the snake the next video. We're going to do the tail of the snake. We are going to do the targets, and we are going to do some more refurbishing. Maybe get a game screen, a title screen I should say, or a menu screen, whatever pops into mind. We could even do different options. And yeah, so thanks guys for watching, and hopefully you guys are able to follow along, and hopefully it's easy to understand. Again, if you have any questions, feel free to drop by the comment section, or come to my Discord channel, and I'll be able to answer your questions, help you out with whatever you need with your code. If there's any errors, feel free to just pop in. Alright, thanks guys, have a good one.